Assalamu alaikum students. I am Khizr Hayat, physics teacher here. Course code 5054/21. Paper physics, paper number 2, theory. Cambridge O level exam. May June 2023. This paper is solved. Question number 1. An aircraft pulls a glider along a runway as shown in figure 1.1. Figure 1.2 shows the speed of the glider during the first 12 seconds. Figure 1.2 basically it is the graph, and it is showing the speed of the glider in first 12 seconds, and time is along x-axis. Now describe the motion of the glider in the first 12 seconds. In the first 12 seconds we have to describe the motion of the glider. In first 6 seconds, body means glider here moves with uniform acceleration. As in first second there is equal change in velocity speed in equal intervals of time, so body moving with uniform increasing acceleration. While during 6 to 12 seconds means last 6 seconds, glider moves with constant velocity. It means there is no change in velocity here in that region, and thus it has zero acceleration as shown. B. In the first 6 seconds of the motion, there is a resultant of the 1800 Newton on the glider. Using the increase in speed in the first 6 seconds, calculate the mass of the glider. As we know, to find the mass, we apply the Newton's second law, F equal to ma. But we don't have acceleration. So first we find acceleration, and acceleration is equal to gradient. Gradient is basically rise by run formula, or change in y-axis to the change in x-axis. So change in y-axis means y2 minus y1 divided by x2 minus x1. So y2 along y-axis we see the graph speed. So we put the values as points mentioned above. 22 is the y2 and y1 is 0, divided by x2 is 6 and minus x1 is 0. As 1 points are origin points, okay, as 0 at the origin, and 2 points are 6 and 22. 6 mean this is the x2 and 22 is the basically value of y2, and x1 is 0 and y1 is also 0 at the origin point. Okay, so acceleration is 3.7 meter per second square. Now F equal to ma and m is equal to F by a. Put the values. Force is 1800 Newton, that is given in the statement, and acceleration we have find. So 486 kilogram is the mass. Determine the distance traveled by glider in first 6 seconds of its motion. During first 6 seconds, you can see that there is a right triangle forming, and we know the area of the velocity time graph gives the distance traveled. So distance is equal to area under velocity time graph, so 1 divided by 2, and that is triangle. So triangle case formula 1 by 2, base multiplied by perpendicular. So base is 6 and perpendicular is 22. So 6 basically 6 seconds, and 22 means 22 meter per second. This is the velocity that is along y-axis, that is called perpendicular. Okay, so answer is 66 meter distance. D. The glider has no engine and stays in air with the use of convection currents. State what is meant by the convection currents. The movement of air molecules in cyclic way due to temperature difference. Okay, this is called convection current. Air molecules movement along in a cycle because of temperature difference, as hot air molecules raise up and cold air molecules move downward, and this cycle continues. This is called convection current. As electric current is due to flow of the electric charges, similarly movement of air molecules is also called convection current. Okay, suggest how the convection current that supports the glider is formed. Answer is, as the air from ground rises up, it forms convection current that causes lift up the collision with the wings of glider and help to stay in the air. Okay. Next is question number 2. In a safety test, a car of 1100 kg travels at speed 10 meter per second and collides with the stationary van of the mass 3000 kg. After the collision, the car and the van move together with velocity v. Figure 2.1 shows the car and van before and after collision. Data also mentioned mass of car 1100 kg, velocity initial of 10 meter per second, mass of van 3000 kg, and velocity initial 0 meter per second mean it is at stationary and then moving with the same velocity. Okay, the total momentum of the car and van is converted during the collision. Define the momentum, the product of mass and velocity of a body is called momentum. Okay, p is equal to mv formula. State the unit of the momentum. There are two units of momentum: kilogram meter per second or newton second. These are both units of the momentum. Anyone you can use in the answer, anyone. Okay, calculate the velocity v of car and van after the collision. After collision, both moving with the same velocity. So first we write data. Initial velocity of car VIC is 10 meter per second. Mass of car MC. C stand for car. Mass of car is 1100 kg. Mass of van 3000 kg. And initial velocity of van VIV. V stand for van. So 0 meter per second. Okay. So final velocity of car and final velocity of van we have to find, and both moving with the same velocity. So final velocity of car will be equal to final velocity of van, that will be equal to v, mean velocity. So applying law of conservation of momentum, total momentum before collision is equal to total momentum after collision. So before collision, mc dot vic mean mass of car dot initial velocity of car plus mv dot viv mass of van plus initial velocity of van. This is the momentum. First we write momentum of car, then plus momentum of initial momentum of van is equal to final momentum of car mc dot v plus final momentum of van mv dot v. Okay, so put the values and we separate. V is equal to 11,000 divided by mc plus mv. So putting the values mass of car and mass of van, we get the velocity of both car and van after the collision when they are moving with the same speed, 2.68 meter per second. Okay, question number 3. Hi Allah, both. G students, question number 3. Figure 3.1 shows the circuit containing 3 resistors, a 12-volt power supply, and an ammeter. So calculate the current in 400 ohm resistor. We have to find the value of the current flowing through it. So applying Ohm law, V equal to IR and I is equal to V by R. But here we have to use the resistor value, that is equal to, as we know in the series circuit, same current flows through the each component. So we have to use the equivalent resistance value to find the current through any resistor. So it is the series combination. To find equivalent resistance, Re is equal to R1 plus R2 plus R3, putting the values 400 plus 200 plus 100, 700 ohm. So to find the current, 12 divided by voltage is 12 divided by R is 700, that is the equivalent resistance or total resistance of the circuit. So current will be 0.017 ampere. Okay, basically same current flowing through the 400 ohm, 200 ohm and 100 ohm resistor. Value of current across each resistor component is same. Understand, as in the series combination, current value along the through the each component is same. So we used equivalent resistance. Calculate the power produced in the 400 ohm. Power produced in the 400 ohm resistor we have to find. So as we have a current value and resistor value is 400 ohm, so P is equal to I square R. Putting the values, we get power 0.115 watt. Student uses at uses all the components shown in figure 3.1 in another circuit. As figure above given, it is it is said that student uses those components in an other circuit. She connects them so that there is a largest possible current in each resistor. So the current in one resistor is larger than the current in other two resistors. The student connects the ammeter into circuit to measure the current in this resistors. Draw this circuit diagram, label each resistor with the value of its resistance. As in this statement, it is clear that value of current through each component is not same. In one component value of current is largest and other components there is different value. It means there will be parallel combination of the resistors. As in the series combination, same current flows. So first we have to draw the again diagram. Okay, and now we have to decide where the ammeter have to place. So ammeter will be placed at the near the resistor having smallest resistance. Where the resistance is smallest, then there is maximum current flow through it. Okay, so this figure in this type we have to draw. Okay, question number 5. A student pushes a drawing pin into wooden board as in figure 4.1. Okay, the area of the pin in the contact with finger is 510 raised to power minus 5 meters square. The student pushes downward with the force of 26 Newton. The mass of drawing pin is very small. Calculate the pressure exerted by the finger on the drawing pin. So pressure formula, force per unit area, force is 26 Newton divided by area is 510 raised to power minus 5. Solve this and we get 5 to 4 times 0. So Pascal, pressure unit is Pascal. Next is compare the force exerted by the finger on the drawing pin with the force exerted by the drawing pin on the wooden board. Force by the finger is equal to force by the pin and in the same direction downward. Okay. Value of force is same. Force applied on the pin and force applied on the uh, drawing pin by the finger. Both forces are same, but value of pressure is different. Okay. Remember this thing. And direction of both forces is downward. Explain why the drawing pin goes into the wooden board but not into the finger. Because of the different surface area. For finger contact area is larger, so pressure will be lower. Okay, while for pin on the board, the contact area below the pin is smaller, so there will be greater pressure value. So P is equal to force per unit area formula. Figure 4.2 shows water emerging from plastic bag that contains a number of small holes as shown. Explain why the water emerges from each hole in the direction at right angle to the surface of the bag. Remember that external pressure affects the angle of emergence. Higher the surrounding pressure causing it to emerge more vertically. Okay. The holes at A and B are the same size. Explain why the water emerges faster from the hole at A than from the hole at B. Okay. As in the figure, A is deeper and B is less deeper. So more deeper hole as point or hole A is deeper, so P is equal to rho GH. Because of greater depth H, internal pressure of water emerges causes to emerge water faster. Okay. Next is the question number 5. Figure 5.1 shows the particles molecules in the sample of liquid water shown. Explain using the ideas about the particles why liquids expand more than solids for same temperature rise. When equal temperature rise for the both substances, liquid and solid, liquids expand more. That is due to movement of the liquid molecules. Okay, as the temperature rises, particles of water or liquid move away from each other, while in case of solids, particles vibrate back and forth or up and down, but remain at their own positions. So we say that expansion in the water is more than the expansion in the solids. You can say water or liquid in general here. In liquid case mean water and gases. Okay, liquid means water and gases. Okay, the boiling point of water is 100 degrees Celsius. State the boiling point of water in Kelvin scale. So we know formula, temperature in Kelvin is equal to temperature in Celsius plus 273. So 100 plus 273, it will be 373 Kelvin, boiling point of water. The temperature remains constant as water turns from liquid to gas at boiling point. As liquid is converted into vapors or a gaseous form, then temperature remains constant. Okay, explain in terms of particles why energy must be provided even though the temperature stays constant, even though the temperature remains constant. Energy must be provided to so that the molecules of water or liquid may able to leave the surface continuously. If we stop providing energy process, then evaporation rate is decreased. Okay, so we have to continuously provide energy so that water molecules or liquid molecules may leave the surface and convert into gaseous form. Okay, see, an electric heater is used to heat the sample of metal as shown in the figure 5.2. There is no thermal energy transferred from metal to surrounding during heating. Okay, the metal has mass of 200 gram and is initially at 15 degrees Celsius T1. The heater is switched on for 2 minutes and then switched off. The maximum temperature reached by the metal is 40 degrees Celsius. Means 2 T1 is the initial temperature and T2 is the final temperature. The power of heater is 20 watt and mass of substance is given 200 gram. Power is 20 watt. Calculate the specific heat capacity of this metal. We know specific heat capacity is represented by C, small c, and Q is equal to mc del T. Okay, but we don't have heat energy, amount of heat energy. So we apply the formula, power is equal to work by energy. Work means energy, heat energy here. Energy is represented by Q, heat energy represented by Q, and divided by T of the formula. So Q will be equal to P dot T by cross multiplying. So Q is equal to P dot T power is 20 and time is 2 minutes means 120 seconds. Okay, so heat energy will be 2400 joule and Q is equal to mc del T. So Q is 2400, m is 0.2 as mass was 200 gram. 200 gram means we have to convert it. So value of the specific heat capacity is 480 joule per kg per degree Celsius. So if we have to convert it by joule per gram per degree Celsius, then answer will be 0.48 joule per kg per degree Celsius, as we have to divide by 1000. Okay. Question number 6 is the virtual reality headset in figure 6.1 contains a display and lens as shown in figure 6.2. Okay, display is the object for the lens. The lens acts as a magnifying glass and forms virtual image of the display. So describe describe where the display must be positioned relative to focal length of lens for the lens to act as a magnifying glass for image on the display. Describe where the display must be positioned. Object must be within the focal point P. Okay, and as display arrows line that is shown on the left side of the lens, this will may be the position of the image. Next is the explain how the virtual image is formed. When object placed between the focus and the optical center, in case of convex lens, then it forms virtual image. And virtual image means image formed by the imaginary intersection of the lines and above the principal axis. Virtual image forms above the principal axis. Okay, these 2 points you have to remember. Virtual image is formed above the principal axis and due to imaginary intersection of lines, not actual intersections. Okay, So that image will be virtual image. Real image forms below the principal axis. Okay. An arrow on the display is 3.4 centimeter from the lens. The virtual image of the arrow is 22 centimeter from the lens. Figure 6.3 shows the arrow O and the lens L. The virtual image of the arrow I drawn on the grid with the scale. Okay. So separation for one cell or distance of the one cell 2 centimeter horizontal and vertical, shown in the graph. On figure 6.3, draw a ray diagram to show the formation of virtual image. So O is the object and I is the image, and this is due to imagine the intersection of lines. This is the virtual image, remember. Okay. Determine the focal length of the lens. So to find the focal length, what is the focal length? Focal length is the distance between the optical center or center of the lens and the focus point. The distance between the focus point and the center of the lens is called focal length. So this is will be 2 plus 2 4 centimeter. Okay, focal length is 4 centimeter calculated here. Next is the a water wave in ripple tank diffracts as it passes through the gap in the barrier, as shown in here. Figure 7.1 shows the drawing made by the student of the crusts in the pattern. State one way in which the student's drawing of the crusts is wrong. How you can say that this diagram drawn by the student is wrong? On the basis of the wavelength, you can conclude that diagram is wrong, because in case of incident waves, wavelength is smaller, while after diffraction wavelength is too larger. That is not possible. The wavelength after the diffraction is too much larger, while lambda remains same after the diffraction. Wavelength should not change after the diffraction. So there is the mistake by the student. Okay. The gap in the barrier is now made smaller than the wavelength as shown in figure. Complete figure 7.2 with at least 3 crusts to show the new diffraction pattern. So new diffraction pattern, as you know, the wavelength should be same, so separation after the diffraction must remain same. So this will be the resultant diagram as drawn. In one part, C option, in one part of the ripple tank, the water has speed 6 centimeter per second and wavelength of 2 centimeter. The wave then passes into the shallower region of the tank. The speed of the wave in the shallow region is 4 centimeter per second. Define the term wavelength. What is the wavelength? Distance between two consecutive crusts is called wavelength. Okay. We can say the distance between two consecutive crusts is called wavelength, or we can also define the distance between crust and the trough is called wavelength. Okay. This may be also the definition. So calculate the frequency of wave. We know V is equal to F lambda. V is 6 centimeter per second. So in meter per second we write 0.06 meter per second. So lambda is 2 centimeter. That will be 0.02 meter by conversion. So F will be equal to V by lambda. Putting the values V and lambda, we get 3 per second or 3 hertz. Frequency will be 3 hertz. Calculate the wavelength of wave in the shallow part of the tank. As we know, V is 4 centimeter per second and V is 0.04 meter per second. V is equal to F lambda and lambda is equal to V by F. So V is 0.04 divided by frequency is 3. So wavelength will be 0.013 meter. Or if we have to convert answer in centimeter multiplied by 100, we will multiply by 100. So 1.3 centimeter. Next is the 8th question number. A filament. Question number 8. A filament lamp is arranged above a shiny metal surface as in the figure 8.1. So student reads in the text book that light emitting diode LED is more efficient than a filament lamp. LED is more efficient than filament lamp. Okay. State what is meant by the efficiency. Efficiency is the ratio between useful output energy to the total input energy. Okay, so efficiency is equal to useful output energy, OP stand for output energy, divided by total input energy or energy provided. This ratio will be equal to efficiency. So just why the efficiency of filament lamp is very low? Because of loss of heat energy, useful output energy is always less than the total input energy, so efficiency is very low. Okay, useful output is so many times, so much less than total input energy, not just less. Okay, as energy is lost in form of heat energy. The student considers the replacing the filament lamp shown in the figure 8.1 with LED of the same brightness. Data about the filament lamp and suitable LED are shown in the figure shown in the table 8.1. Filament lamp input power 120, efficiency 6.2%, LED 15, and efficiency energy efficiency we have to find. Okay, so we use output energy is equal to efficiency multiplied by input energy. So output energy is x multiplied by 15. X is the basically energy efficiency that we have to find, multiplied by 15 is the efficiency, so is equal to efficiency of the filament 6 and multiply the input energy, so 6.2 multiplied by 120, so we get x value 50%, so efficiency will be 50%. A filament lamp is connected to the live and natural wires in the main supply. The earth wire in the main supply is connected to the shiny metal surface shown in figure 8.1. There is a fuse in live wire. By accident, a live wire touches the shiny metal surface. Describe what then happens. Current flows through the shiny metal surface. As shiny metal surface is grounded, current flows to the ground, but fuse may blow due to excess flow of the current. Okay. Next is in another similar lamp, the fuse is wrongly connected into earth wire. Explain why a person is not protected when the live wire touches the shiny metal surface. As the metal is still live, metal surface is still live even after the fuse blow, so person is not protected. Okay. Question number 9. Figure 9.1 shows the simple AC generator. Explain why there is voltage induced in the coil when coil is turned. Because of turning of the coil, magnetic flux in the coil is changed. So because of change of magnetic field or magnetic flux, voltage is induced. By Faraday law, rate of change of magnetic flux is equal to causes to induce EMF. Okay. B is in figure 9.1, the coil is horizontal with side AB on the left. The output voltage is 6 volt. On the figure 9.2, the draw line from each of the shaded boxes to one of the circled voltage to show the voltage output when the coil is in different positions. One line has been drawn for U. Coil horizontal with AB on the left 6 volt. Coil horizontal with AB on the right minus 6 volt. Basically answers are according from this diagram. AB is the side of the coil of the length. Okay. So coil vertically with AB on the top, then value of voltage will be 0, and coil vertically with AB on the bottom, then again value of the induced EMF will also be 0, because in these both cases there is no change of magnetic flux when coil is in vertical position here. So no EMF is induced. EMF is induced because of changing magnetic field in coil. Okay, so remember this point. Both an AC generator and DC motor contain a coil and brushes. In figure 9.1 shows how the brushes are connected to coil in an AC generator. Draw a diagram to show how the brushes are connected. So carbon brush is shown in figure. In such format, carbon brushes are connected with the generator. State why there are forces on the sides of the coil and DC motor. Why there are forces up and down forces. So then coil rotates because of flow of current due to varying magnetic field. Okay. Carbon 14 is an isotope of the carbon. It undergoes radioactive decay with half-life 6,000 years. The age of sample wood is found using carbon 14 that it contains carbon 14. This technique is called carbon dating to find the age of the substance on the basis of their radioactivity or decay rate. This technique using a carbon 14 isotope that is called carbon dating. So question is describe what happens during the radioactive decay. Radioactive During radioactive decay, alpha, beta, and gamma radiations are produced. Okay. The count rate of the carbon 14 in the sample would initially 1600 counts per minute, as in the graph shown along y-axis, and figure 10.1 draw a graph to show how the count rate will vary over the next 24,000 years. You can see the graph and points mentioned. Next is the name the apparatus used to measure the radiation from the sample of wood and describe how it is used to measure the count rate. Apparatus used. What type of apparatus is used? GM tube that is called Giger Muller tube. How the apparatus is used? It measures the number of the radiations emitted by the radioactive substance in the given time without considering the background radiations. Okay. Describe how the count rate from a sample of wood is used to find its age. By drawing graph between count rate versus time helps to find age of the sample. Okay. As count rate of the radiations is decreased, so how much count rate is has been decreased with the passage of time. On basis of that count rate, we can guess the age of the sample. Okay. So here is question number 11. Table 11.1 shows the details about the 8 planets in the solar system, their average distance from the sun, their orbital speed, and their average surface temperature. Table 11.1. For what planet distance from the sun in kilometer is 5.8 10 raised power 7? So that is Mercury. And for what planet distance is 7.8 10 raised power 8 and its surface temperature minus 110? That is the Jupiter. And next is the sun to planet distance 2.9 10 raised power 9 and its surface temperature minus 195 degrees Celsius. That is Uranus. Okay, complete the table 11.1. So we have completed. Calculate the orbital speed of the Mars as it travels around the sun. So speed is distance by time. Distance is 2 pi r as they are moving in the circular path. So circumference of the circle is considered 2 pi r. Divided by time value. Time is given in the table. Okay, so 5.9 times this power 7. So 2 pi, and radius of the Mars is 2.3 times power 8. So putting values, we get 24.5 kilometer per second orbital speed. Describe the relationship between distance of planet from sun and its orbital period. As the distance from the planet is increased, orbital period also increases. Describe the relationship between the distance from sun and average surface temperature of the planet. If your description in your description include any anomalies. It is said that focus on the figure where is an unusual behavior you observe. In the first on the column of the average surface temperature, you see notice 167 temperature for the Mercury, then Venus 465, and then 15, and then minus 65. After 464, below temperature is continuously decreasing, but in first two cells the temperature increased. 167 lower and then 464 increased. So this is the anomalous behavior. uh, so a distance of planet from sun increases, its temperature decreases, except Venus, as we observed in the figure. So in this way this paper ended. More papers also uploaded. You can also watch them and understand. If I have any question, then comment below. Okay, Allah Hafiz.